Hey, what's going on, guys? So this week we are going to learn, one of the topics we're going to learn about is solving quadratic functions by factoring. Okay, and so we're gonna go through this worksheet together. But I thought before we do that, I've got a couple number riddles for you. Okay? So before I started this video, I programmed a couple numbers into my calculator. Okay, only I know what the numbers are. Okay, but I'm going to give you some clues and see if you can figure out what my numbers are. Okay. So the first thing is that I saved two numbers here, and I saved them as A and B. Okay. And when you multiply my two mystery numbers together, okay, you get a product of 0. Okay. Now, go ahead and pause the video for a moment if you want and see if you can figure out what my two numbers are. All right, so here's the answer. Okay. So we know that when we multiply these two numbers, we get an answer, a product of 0. Okay. Now there's really only one way that can happen, right? If one of my two numbers is 0, right? So maybe my first number is equal to 0, or maybe my second number is equal to 0, or maybe both my numbers are equal to 0, okay? But we know at least one of these numbers has to be 0, okay? So maybe you guessed that A was 0. Well, now I'll reveal to you what number I saved as A. A was actually 4, okay? So now that you know that A was 4 and the product is 0, right? We know for sure that B has to be 0, okay? And so here it is, right? B is 0. All right, let's try the same kind of number riddle again, but this time I'm only thinking of one number, okay? And so let's take my number, which I called n, right? And then I'm gonna take my number and subtract 1, okay, and multiply it with the original number. And again, the product is 0, okay? So can you figure out what number I'm thinking of? Right. I'm taking my number, and I'm taking my number minus 1, and I'm multiplying those two quantities together. Okay. Right. So here's how we can think about it, right? There's a number, and then there's that same number minus 1, and when we multiply, we get 0. Well, since we know the product is 0, okay, it tells us that either the original number is equal to 0, or this factor here, right, the n minus 1, maybe that factor is equal to 0. Okay. So basically what we've established is maybe the original number is 0, or perhaps the number minus 1, maybe that expression is equal to 0. Well, this could be a solution, okay, but this isn't quite a solution yet, right? We haven't solved for the variable. But if we just add 1 to both sides, right, now we get another possibility that perhaps the number was 1. Okay. So now I'll reveal what the number actually was. The number was 1. Okay, which we figured that out. We knew it was going to be either 0 or 1. It just happened to be this solution. All right, we're going to do a couple more of these riddles and then we'll get into the worksheet. All right, so next riddle is I'm thinking of a new number. And what I'm going to do is I'm going to take my number, which is called m, and I'm going to add 2. And then I'm going to take my number and add 5. And then I'm going to multiply those two things together. Okay, so my number plus 2 and my number plus 5, and then let's multiply those. Okay, and when we do, we get 0 again. There's a theme here, is that every riddle I'm giving you, right, the product is 0. Okay, that's going to tie into the property that we learned today. All right, so let's write this down on our paper, right? We've got some number plus 2 and the same number plus 5, and when multiplied, we get 0. Now, even an elementary student can tell you that when the product is 0, you must have multiplied by 0 at some point. Okay? So perhaps this expression is what's equal to 0, or perhaps this expression is what's equal to 0, but we know at least one of those expressions has to be 0. Okay. All right, so let's set up two very simple equations and solve them. Okay, so maybe the expression m plus 2 is 0, or perhaps the expression m plus 5 is equal to 0. All right, so we'll subtract 2 from both sides there. We'll subtract 5 from both sides there. And so we get m equals -2 or m equals -5. Okay, so we don't know for sure which of these two solutions is correct. Okay, I'll reveal the answer on my calculator because I, saved it ahead of time. But we know at least one of these answers is going to be correct. Okay, so now for the big reveal, m was -2. Okay, which we deduced that. Okay, let's do one more. Okay, this one's going to be a bit more of a challenge. Okay, so I have a new number, and this time I'm going to multiply my number by 2. Okay, I saved it as k, and subtract 1. But I'm also going to multiply my number by 3 and subtract 1. Okay. So I'm multiplying my number by 2 and subtracting 1. I'm also multiplying my number by 3 and subtracting 1. And then I'm going to multiply those two expressions together, right? Those two results. And lo and behold, the product is 0. So write this out as an equation. So a number times 2 minus 1, and a number times 3 minus 1. And when we multiply those two results together, we get 0. So we can deduce that either the first expression is equal to 0, because 0 times whatever this would be 0. Or maybe it's the second expression that's equal to 0, right? This could be anything, but if this is 0, then we're going to get a product of 0. All right, so let's create two equations now. So maybe the expression 2k minus 1 is what's equal to 0. Or maybe it's the expression 3k minus 1 that's equal to 0. Right, so to figure out what k is in this equation, we would add 1 to both sides. And get 2k equals 1. And then divide by 2, you get k equals 1/2, 0.5. Or to figure out what k is in the second equation, again, now we have just a linear equation. We add 1 to both sides. We get 3k equals 1. And then we're going to divide by 3. And we get k is approximately 0.3 repeating. All right, so two possibilities, right, for what my mystery number is. Maybe it's 1/2, maybe it's 1/3. Okay, I'll show it to you now. So it was 1/2, 0.5. Yeah. All right. So what's the point of all this, right? Why am I giving you all these number riddles where the product is 0? Okay. So it turns out that this type of math is going to help us solve quadratic equations. Okay. And the way it works is because quadratic equations, many of them can be factored into expressions that look like this, right? Some linear factor times another linear factor. So that's kind of like the key for how this type of math is going to help us with quadratic functions. All right, so let's take a look at our notes here. So to find the solutions to a quadratic equation, factor the equation. Okay, so that's key. Factor the equation, and then use the 0 product property. Okay, and that's what I was presenting to you with those 4 number riddles, right? The 0 product property, right? If you multiply two quantities together and the answer is 0, then one of those quantities has to be 0, which is what it's saying here, right? If I have A and B and the product is 0, then one of those two variables has to be 0. Maybe it's A, maybe it's B. Could be both, right? But at least one of them has to be 0. All right, so here is an example, right? It says find the roots of 2x squared minus 8x, right? So that's a new word, right? Roots. We might get more into this in a future video, but so the roots are going to be the solutions to the equation, right, when we set it equal to 0. Okay. It also represents the x-intercepts, right? If we were to graph this quadratic function, graph the parabola, right, the roots are going to be the locations where it crosses the x-axis. All right, so what we should do is we should, well, what do they do first? They factor it, okay? And so this quadratic just has a greatest common factor, which is 2x, and the remaining terms are x minus 4, okay? And then they set the equation equal to 0, right? That's to take advantage of this zero product property. Okay. And so I would probably even put parentheses around here to recognize that I have two factors, right? 2x is the first factor, x minus 4 is the second factor, okay? We know that at least one of those has to be 0, okay? So they set up two equations and solve, just like what we were doing with those number riddles. Now, before we go any further, let's just talk about factoring, okay? So this is a very important skill to be successful in solving quadratic functions, okay? Now, we went over maybe 2, 3 main ways of factoring. The first being the greatest common factor, which is actually being used right here, okay? Another method of factoring is the box method or the area model. Okay, that's super useful when you have 3 terms in your quadratic expression. Okay, and another one kind of related to the area model is the difference of squares. Okay. So those are perhaps the 3 most commonly used factoring methods. Okay. Greatest common factor, area model, and difference of squares. All right. So we've got 3 examples and then 3 problems for you to try. Let's just go ahead and take a look at the first example. All right. So first, let's identify the quadratic function. Okay. And quadratic functions have a second power to them. So I can see here I have 4g squared minus 40g. So this is my quadratic function. I'm just going to label it QF. And in order to take advantage of the zero product property, right, this quadratic function has to be equal to 0. Okay. So what we really want is this y variable. We're just going to assume that it's 0. So now we've got 4g squared minus 40g, right, the quadratic function. Now we're going to set it equal to 0. All right. So now for the most crucial step, which is the factoring step. I'm going to do this off to the side. So we have 2 terms in our polynomial, right? And so let me just set this up with 2 boxes, right? 4g squared and then minus 40g. All right, and so I'm going to use the area model, right, to figure out what these factors are. Okay, so when I look at these 2 terms, I can see that they're both divisible by 4, and they both have at least 1 power of g. Right. So I know that one of the factors is going to be 4g. All right, now what terms would I multiply by to get the terms inside the box? Well, if I multiply 4g by another power of g, that will be 4g squared. If we multiply 4g by negative 10, right, then we get the product negative 40g. All right, so using the area model, we've figured out that the factors of this quadratic function are 4g and g minus 10. So now we're going to write that in. 4g, g minus 10. And we know that the right-hand side is 0, right? So the product of these two factors is equal to 0, which, just like our number riddles, right, tells us that perhaps the first factor is equal to 0, or perhaps it's the second factor that's equal to 0. One of these has to equal 0 if the result is 0. All right, so let's set it up. Take the first factor, set it equal to 0. Or let's take the second factor and set that equal to 0 as well. So if we divide both sides here by 4, we get g equals 0, possibility. If we add 10 to both sides there, we get g equals 10, the other possibility. So the solutions, the roots of this quadratic function are 0 or 10. Now, how can we be absolutely sure that we got the right solutions? Well, we're going to check our answer. So let's do a quick check. All right, so what we're going to do is we're going to take the equation and substitute our solutions for g. Okay, so it was, let me zoom out some. So we had 4g squared minus 40g equals 0. So notice I didn't technically write g, I just left an empty placeholder. And now I'll test out the first solution, 0. Well, I know 0 squared is 0. And if you multiply that by 4, it's 0. 40 times 0 is 0. So we have 0 minus 0 equals 0. Of course, 0 minus 0 is still 0. And so we can see that 0 solves the equation, right? It makes this equation true. Okay. All right, let's test the other value, 10. Okay. So go back to the original equation, and then I'm just going to replace the g's with empty placeholders. Right, so it was 4g squared minus 40g equals 0. And now we'll test out the value 10. All right, so 10 squared is 100. So this will be 4 times 100 minus 40 times 10 equals 0. Okay. 4 times 100 is 400. 40 times 10 is also 400. 400 minus 400 is 0. Okay, so again, we get that both of these values make the equation true, right? They make both sides of the equation the same value. So let me show you a second way that you can check your answer, besides just kind of running through the math, is let's use Desmos. Okay, so I'm going to switch my camera for just a second. This is one. Maybe this one. Okay. All right. So I'm going to go over to switch over to Desmos, and I'm going to type in that quadratic function. Okay. I'm not going to type the whole equation, just the function. It was 4g squared minus 40g. Now, Desmos is not reacting to this. I think they prefer we use x instead of any other letter. So let's just change the g to an x. See if that, yeah. Okay. All right, so g, x, ABC, doesn't matter what letter you use. So here was the quadratic function, okay? And we can see, oops, let's zoom out. Right, that produces a parabola. Okay. There's the vertex way down there. Okay. So let's zoom in and see, where does this parabola cross the x-axis? It crosses at that point there and that point there. Look at the x-coordinates, 0 and 10. Okay. Which were, I'm going to switch back again now, the two solutions that we found using algebra. Okay. Switching back. So there it is, right? So 0 and 10, right? Those were the solutions we found. And when we checked using, the graphing calculator, we saw that those were the two locations where the function, the parabola, crosses the x-axis. All right, cool. Let's look at number 2 now. So again, we want to identify the quadratic function. Okay, so just look for the expression that has a second power to it. Right, so y squared minus 4y minus 12. That's our quadratic function. And you can see that this one is already set up so that it's equal to 0. Okay, so we don't have to write that part in ourselves. All right. So this is probably the part where you're going to spend most of your mental energy is trying to factor this. Okay. So I'm going to go ahead and use the box method here. Okay. So I know the second degree term is going to go in the first box. The constant term is going to go in the last box. These two diagonals, okay, I know have to add up to the middle term. All right, so it's got to add up to negative 4y. But I also know that these two diagonals are going to have the same product as the opposite diagonal. Right, so what do those two multiply to make? Negative 12y squared. Okay. So there's only two terms that can resolve both of these clues. And that would be negative 6y and positive 2y. Right, if we add them, we get negative 4y. And if we multiply these, we get the same product here, negative 12y squared. All right, so that's just a reorganization of the quadratic function, just organizing 3 terms into 4 terms, okay? But now we're gonna do the actual factoring, okay? What are the factors of y squared? Oh, it's just y and y, okay? What factor do we need here to make the product 2y? Well, we would need a 2 there. What factor would we need here to make the product negative 6y? We would need a negative 6. Okay, so y plus 2 and y minus 6 are going to be our factors. All right, so y plus 2 and y minus 6. Okay, so we've taken that quadratic function as a 3-term polynomial and rewritten it as 2 factors. And yes, it's still equal to 0. And because of that, right, we know that one of these 2 expressions has to equal 0. Okay? Maybe it's the first one, right? 0 times anything is 0. Or maybe it's the second one, right? Whatever this is times 0 would still equal 0. All right, so now we're just going to set up 2 equations, right? Take the first expression, set it equal to 0, and take the second expression, y minus 6, set that equal to 0. And yeah, you can probably do, solve this mentally. I'm just going to work out every step, just, for the sake of completion. So yes, we're going to subtract 2 from both sides. Get y equals negative 2. And then we're going to add 6 to both sides here. And then we get y equals 6. All right, remember there's 2 ways we can check. We can check algebraically by substituting these values one at a time, okay, back into the original equation, and we can check graphically as well. All right, so let me just check algebraically. Okay, so the original equation was y squared minus 4y minus 12 equals 0. And let me test out the first solution we got, negative 2. Okay, so when we square negative 2, we get positive 4. A negative times a negative is a positive, so that'll be positive 8. 4 and 8 adds up to 12. And then we're going to subtract 12. And yes, 12 minus 12 is 0. Okay, so we can see that the first solution we got actually works. And then we'll test out the second solution. So the original equation was y squared minus 4y minus 12 equals 0. And then let's test out 6. Okay. 6 squared is 36. Let's see, 4 times 6, that's going to be minus 24, minus 12 equals 0. Okay, so 36 minus 24 is 12. We're going to subtract 12 again, and we get 0 equals 0. Okay. So both of those two solutions work, right? -2 solves the equation, okay, produces the same value on both sides. +6 solves the equation, it produces the same value on both sides. Let's see what this looks like in Desmos. Okay, so I'll switch back over. And let's go ahead and type in the quadratic function only. Okay. Now, we had y's in the original problem. I'm just going to change them to x's. Okay, so I'll write x squared instead of y squared, minus 4x instead of minus 4y, minus 12. Okay. You can see there the shape of the parabola. Right, its vertex is down there. But what we're going to zoom in and focus on are the locations, okay, where it hits the x-axis. So it hits there at -2, and it hits over there at +6. Those were, in fact, the solutions that we found. All right, switching back over, we're going to do the third example. Sorry, it just takes a second for the cameras to switch. Okay, so x squared minus 9. So because that's a second power, right, we can recognize that this is our quadratic function. Okay, but in order to solve it, we need to set it equal to 0, right, so that eventually we can use that 0 product property. All right, so just like what we've been doing, the first thing we're going to do is we're going to factor the quadratic function. So you might recognize that's a difference of 2 squares. Okay, if not, the area model still works pretty well, right? Second degree term goes in the first box, constant goes in the last box. Okay, the diagonal terms have to add up to the middle term, which there is no middle term, so then it adds up to 0. I'm just going to write 0x. And then these two boxes have to produce the same product as the other diagonal. And when you multiply those, you get -9x squared. So, because it has to add up to 0, we know these have to be opposites, and it's got to multiply to that. So it's 3x and -3x. All right. Now let's find the factors. So x squared is the product of x and x. -3x is the product of x with -3, and 3x is the product of x with +3. Okay. So our factors are x plus 3 and x minus 3. Okay. Again, I'm sure many of you probably recognize that right off the bat. So, again, I'm going to work everything out, but do you have to write out all these steps? Probably not. You can do a lot of the math mentally. All right, so our quadratic function can be written as x plus 3 times x minus 3. And we know that the quadratic function is equal to 0. So we still have to write equals 0. And then here's where that 0 product property comes into play. The only way to get an answer of 0 is if one of the things that you're multiplying by is 0. So maybe that first expression is 0, or maybe that second expression is 0. All right, so what we're saying is maybe x plus 3 is equal to 0, or maybe x minus 3 is equal to 0. Again, you can probably solve these mentally. I'm going to do all the steps. Subtract 3 on both sides there. Add 3 to both sides there. X equals -3, or x equals +3. All right, let's do a quick check. Okay. So take the original equation, right, was x squared minus 9 equals 0, and test out each solution one at a time. Okay. Let's test out -3. Well, when you square that, you get 9. 9 minus 9 is 0, which is the same as 0. So -3 is a solution. It makes the equation true. All right, and then now let's test out the other solution. All right, so the equation was x squared minus 9 equals 0, and we're going to test out 3. 3 squared is also 9. 9 minus 9 is still 0, at least in my universe. And 0 minus 0 is 0. I'm just going to switch over so that we can see what this looks like in Desmos. All right, so our quadratic function was x squared minus 9. And if you take a glance here, you can see that the locations of the x-intercepts are at -3 and +3, okay, which were, in fact, the solutions we had. All right, so we've gone through the 3 examples. All right, so if you're following along on your worksheet, where's mine? Okay. All right, so we've done examples 1, 2, and 3. Okay, so now I think you should pause the video and try the 3 U-try problems on your own. And then when you're ready to check your answer, unpause the video, and then I'm going to go through those solutions. So U-try number 1. Now, I'm just going to write out the solutions. I'm not going to go in as much depth as I did the first 3 problems, just because I don't want the video to be super long. All right, so we have our quadratic function here. Okay, we know that's the quadratic function because it has a second power. Okay, and to solve it, we want the quadratic function to equal 0. Okay, so where that y is, I really want there to be a 0. Right, now you're going to want to factor this. I'm just going to do it mentally, but you can work it out using the area model, whatever technique you want. But I see that this is a difference of 2 squares, right? 4 is a perfect square, x squared is a perfect square, 9 is a perfect square. So I recognize that this is going to be, 2x plus 3 and 2x minus 3, right? That's the factorization of that quadratic. So now I have 2 factors whose product is 0. And we can deduce that one of these 2 factors is 0. Okay, so we just have to create 2 equations. Okay. 2x plus 3 equals 0, or perhaps the other expression, 2x minus 3, is what equals 0. These are going to be 2-step equations. They require addition, subtraction, and some sort of division. So I'm going to subtract 3 first. 2x equals -3. Divide by 2, and we get x equals -1.5. Okay, you could leave it as a fraction too if you want. Okay, for the other equation, we're going to add 3 to both sides. So we get 2x equals +3, and divide by 2, and so we get x equals +1.5. So I would encourage you to check your answers using algebra, right? Plugging it back into the original equation. Or if you want to quickly check your answer, just type this function into Desmos and look for those x-intercepts. All right. Here's U-try number 2. All right, so identify where the quadratic function is. It's right here. Okay. We already have it set equal to 0, so that's very nice. Okay. We're going to factor this. Okay. I would use the area model, but you might also recognize that there's a greatest common factor, right? Both terms are divisible by 5, and both terms have 1 power of z. So we're going to have a factor of 5z. And then if we think about what factors would be remaining, well, we would have a z there and a 9 there. Okay. And you can just, in your head, just do the distributive property, right, with these expressions. So now that we have the quadratic function factored, and we know that the product is 0, then we can safely say that one of these two expressions, one of these two factors is equal to 0. So perhaps it's 5z that's equal to 0, or possibly it's the z plus 9, which is equal to 0. Okay. Either way, let's solve. Okay. Divide by 5, and we get z equals 0. Subtract 9, and we get z equals -9. All right, and that takes us to our last U-try problem. And so all I see here is a quadratic function, right? So 3 terms, trinomial, right? N squared minus 10n plus 9. It's not an equation yet. It's just an expression. So in order to make it an equation, we have to set it equal to some number, and that number is going to be, you guessed it, 0. All right. If you don't recognize the factors of this right away, then for sure I would recommend the area model, or the box method. I can see that n squared is n times n. 9 could be 3 times 3. It's not going to work. It's going to be 9 times 1. And then since the middle term is negative, okay, I think both of those have to be negatives. You can see a negative times a negative would produce a positive 9. Okay, anyways, I'm rambling here. So we factored our quadratic function into these two expressions, 1, 2, and the product is 0. So one of those expressions has to be 0. All right, so maybe it's n minus 9, which is equal to 0, or maybe it's n minus 1, which is equal to 0. So let's add 9 there. Get n equals 9. Let's add 1 here. And we get n equals 1. All right, so I hope that you found this video helpful. Again, I'm sorry that I didn't go into as much depth in the last 3 problems. I just want to keep the video kind of short, but you can go back and look at the first 3 in which I went into more detail. I showed all the factoring, and I checked my answer using algebra and using Desmos. Okay. So yeah, really encourage you to use Desmos, right? You guys are learning at home right now. You don't have, you're not, having that face-to-face time with your teacher. So you need to use other resources right now to help you better understand, in this case, quadratic functions. So Desmos is a very powerful tool, which you definitely should be taking advantage of right now. Okay, so that's it for this video. Thank you so much for watching.